Hello guys and welcome back to the Maths and Physics blog. Today we're going to go over our second video in our lenses video. So we got thick lenses last time and thin lenses now. These are all in our waves and optics playlist, so make sure you go back and watch all the videos if you're interested in this topic. So let's begin. So we had these equations from last time in our thick lens video, and then we can combine these two relationships to get a relationship between the distance of the second image created from the double refraction we did and the object of the first object. Now, if we assume that the lens has a negligible thickness, then we can assume that the object of the second distance is equal to the minus the image of the first one. So, if we continue this math, we see that we give our values for the equations we had from the last videos, 1 and 2, and then if we substitute into the second equation, we get this equation here. And then add this to the first equation, we get this. So I'm not going to go say what they are, I just expect you to you can pause and have a look and see how they've been going through. So now we can denote that the object distance equals the distance of the first object, and that the distance of the image is equal to the distance of the second image. So this is essentially taking our thick lens and then just making it super small and forgetting about the image of the first object, the first image, and the second object. So if that makes sense, because it's kind of cancelling out the two refractions we did in the last video and making it all into one. So we get this equation at the bottom here. Now, if we think about the focal point, which we know that the focal point is where all parallel rays converge, we have a video on that in the playlist, make sure you go watch that. And then we set the object distance to be infinite, and then we set the image distance to be the focal point. We get the lens maker's equation here, which is quite important, which gives us 1 over the focal point is equal to the change in the refractive index divided by the reflective index of the outside over 1 over the first radius over the second radius. And then this can then give us the thin lens equation, which is very important. This is more important than the lens maker's equation here. So in conclusion, from the equations, we found that we're able to apply them to many problems. So we have a convergent lens here, so we can see that this light goes into the lens and then it converges to a point. But then we can also have a divergent lens, which will give us a real image on the same side as the lens, or a virtual image. So thank you guys for watching. I hope this makes sense. It's much easier to understand if you've watched our thick lens video also any other video in our playlist. But thank you guys for watching. Make sure to hit like and subscribe, and I'll see you guys in the next video. Goodbye.